Number 8, a model rocket is, a block of mass 2 kilograms is placed on a smooth plane and the inclination of the plane is 15 degrees. So this is like a classic problem where you have an inclined plane. This one is 15 degrees and we have a mass, an object resting on that plane. It says smooth plane, so we know there is no friction. So what are the forces acting on it? Well, we have gravity acting straight down, and we have the normal force perpendicular to the surface, so Fn and Fg. Are there any other forces acting on this? No. We know that it is going to slide down the plane, and the reason is because there is an imbalance. The normal and the gravitational force are not exactly opposing each other, so there's a slight imbalance down the plane. So when we let go of this block, it's going to accelerate down the plane. So now we have to figure out, in question A, what is that acceleration? Well, this is one of those cases where we're going to rotate our axes. So in this case, we're going to have an x-axis that's sort of in that direction, down the slope, and the y is perpendicular, so like this, y. Since it's asking us about the acceleration, we can start this problem off by looking at it in the y direction, in the x direction, but you can see that the normal force is in the y, the gravitational force is not. It's partially x and partially y. So what we're going to do is start off by breaking it into its components. And the components are always perpendicular to the x and the y axis. So here are two vectors, Fg in the x direction and Fg in the y direction, that represent the components. Since this angle's 15, we do our same little, which would make this angle 75 degrees, according to our right angle trig. Okay, so let's start off the way we always start off a problem. F net equals MA. MA equals the sum of the forces. And I should point out here that we are actually looking at this along the plane. We're not trying to do the whole thing at the same time, although you could. We're just looking at along the plane. So, and by that we mean the x direction. We can call this the positive x direction and this the negative x direction. So what we're seeing here is that the only force acting in the x direction is the force of gravity in the x direction. So MA, the sum of the forces simply comes down to just F, G, X. So what is FGX? Well, let's look at that triangle. We can see that it's adjacent, so FGX is going to equal FG times a cosine of 75 degrees, right? And another way you can think of that is, well, we know that Fg equals, we also know that this Fg is equal to mg, right? So another way to say this is mg cosine of 75 degrees. And you can plug in all those numbers, we have them all, and you can get a number, but I'm just going to leave it as an expression right now. Okay, so then plugging this whole thing back into here, we're going to get MA equals mg cosine of 75. You can see in this case that the m's actually cancel out, so you're left with A equals, and it's 9.8 times the cosine of 75. And that works out to 2.6 meters per second squared. And that's the answer to part A. It's interesting that the masses cancel out. What they're saying is it doesn't matter what the mass of that object is, it will still have the same acceleration. Mass is independent. Okay, so then for part B, what we're going to do is look at the kinematics. So for part B, it tells us that they want to know how far up the plane. So what is that quantity? So I'm just going to start by, I can see that it's a kinematics problem. I'm going to start by listing all the stuff I have. I already know that A is 2.6 meters per second squared. I know that how far up the plane was a block released if it took 1.5 seconds, so 1.5 seconds to reach the bottom after it was released from rest. So from rest is 0. and they're asking us delta x, and we don't know, don't care about v. So that's our unknown. So delta x equals VO delta t plus 1/2 AT squared. And then solving this, we would get, that cancels out, 1/2 of 2.6 times 1.5 squared. And the answer is 2.9 meters.